Good morning, students. Local field or internal field or Lorentz field. Suppose when a dielectric material is exposed to an external electric field, then dipoles will be induced. That means polarization will take place. Now let we calculate the ultimate E local field or internal field or Lorentz field. Suppose see here, this is a dielectric material. This dielectric material is introduced between the plates of a parallel plate capacitor. That means here this is a parallel plate capacitor, and in between the parallel plate capacitor we have inserted a dielectric slab, dielectric material. When the dielectric material is introduced between the plates of a capacitor, then different sets of dipoles will be induced at inside of the material. Suppose see here, if it is a parallel plate capacitor, poles positive charge will be there on left side or negative charge will be there on the right side. And if we are just introducing the dielectric slab in between the plates of a capacitor, opposite charges will be induced. At that time, we can calculate the local field or internal field or Lorentz field at a point A at inside of the dielectric material as E local is equal to E naught plus EP plus ES plus EM. See, what is meant by E naught? E naught is the charge intensity at point A due to the induced charges on the plates of a parallel plate capacitor. What is meant by EP? EP is nothing but field at point A due to the charges induced on the surface of the dielectric material. What is meant by ES? ES is nothing but field at point A due to the charges induced on the surface of the assumed sphere. And EM is nothing but field at point A due to the dipoles induced inside of the spherical material. So here E naught, EP, ES and EM, and we know that the electric displacement vector D is equal to epsilon naught E, and from this E is equal to D by epsilon naught. And E local can be, at final we can write E local is equals to E plus ES. E means E naught plus EP plus EM. The summation of all these values, that means field intensity at point A due to the charges induced on the surface of the parallel plate capacitor plus field at point A due to the charges induced on the surface of the dielectric material plus field at point A due to the dipoles induced at inside of the spherical cavity. And here we know that ES is nothing but the field at point A due to the charges induced on the surface of the spherical cavity. Now let we calculate the value of ES and then substitute into the equation number 1. Then we get the value of E local is equals to E plus ES. Right. See, here it is the spherical cavity. Here there is a point A. This is the sphere, and these are the charges induced on the surface of the sphere. And see, let us suppose that here, let us divide the entire sphere into number of area elements in order to calculate the value at field intensity at point A. Now here this is the smallest area element dA. If suppose dA is the area of the area element, then this dA can be calculated as dA is equal to 2 pi into PQ into QR. dA is equal to 2 pi into PQ into QR. Now we can calculate the values of PQ and QR as from this triangle APQ, from this small triangle APQ. Here it is a triangle and we know one angle. We can calculate any side. From this we can calculate the value of PQ. So from this triangle APQ, sin theta is equal to opposite side by hypotenuse. So opposite side PQ by hypotenuse AQ. That means AQ is nothing but the radius of the sphere is R. Here we can write the radius of the sphere is R. So that sin theta is equal to PQ by R. From this PQ is equal to R sin theta. Let it be equation number 3. And also here we have one sector AQR. This is a sector. This is a sector AQR. From this sector, the solid angle can be written as arc by radius. So what is arc? QR by radius AR. QR by AR. That means QR by AR means small r. R is the radius of the sphere. So dq is equal to QR by R. From this QR is equal to R into d theta. So we calculated the values for PQ and QR and then substitute into equation number 2. We get dA is equals to 2 pi. That means 2 pi into r sin theta into r d theta. So dA is equal to 2 pi r into r square, 2 pi r square sin theta d theta. So this is the area of the area element. What we are doing, we are just dividing the entire sphere into number of area elements. If dA is one of the area element, the area of the area element is 2 pi r square sin theta into d theta. Now let us suppose that there is charge is there on the surface of the area element dA. That charge is called as dq. Let us suppose that dq is the charge accumulated on the surface of the area element dA, and that dA should equals to, that can be that dq, the charge dq on the surface dA is equals to the normal component of polarization which is multiplied by the area element. So the normal component of polarization is p cos theta, and then that shall be multiplied by the area element dA. So dq is equals to p cos theta into dA. So p cos theta into, we know the value of dA from equation number 5. Substitute equation number 5 in equation number 6, we get p cos theta into 2 pi r square sin theta d theta. dq is equal to p into 2 pi r square sin theta cos theta d theta. Right. So the field due to the charges dq is denoted by des at A along the direction theta is equal to 0 degrees. So des can be written as des is equal to 1 by 4 pi epsilon naught into dq cos theta by r square. So des is equal to, we know the value of dq as p into 2 pi r square sin theta cos theta d theta. This is the value of dq, already we calculated. And then here we have cos theta divided by 4 pi epsilon into r square. So r square cancelled out, 2 pi 4 pi 2 times cancelled out. So des is equals to p by 2 epsilon naught remaining, p by 2 epsilon naught into cos theta into cos theta, cos is square theta into sin theta d theta. Let it be equation number 7. So if you know the value of des, we can calculate the value of es, because es is equal to integral des. In between the limits from 0 to pi we apply. So integral 0 to pi des is equals to constant p by 2 epsilon naught into integral 0 to pi cos square theta sin theta d theta. Now let us suppose that cos theta is equals to x. That means sin theta d theta is equal to minus dx. If we apply and change the limits, we can write es is equals to p by 2 epsilon naught into integral, that means if theta is equal to 0, x is equal to plus 1. If theta is equal to pi, x is equal to minus 1. So p by 2 epsilon naught plus integral minus plus 1 to minus 1 x square into minus dx. If we change the limits, we can reduce the sign, so that es is equal to p by 2 epsilon naught into integral in between the limits from minus 1 to plus 1 x square into dx. And if we are doing integration, x cube by 3 in between the limits from minus 1 to plus 1, we get the value of p by 3 epsilon naught. This is the value of es. So es is equal to p by 3 epsilon naught, and substitute this equation number 8, the value of equation number 8 in equation number 1, we get E local is equal to E plus P by 3 epsilon naught. That means E local is equal to E plus ES, E local is equal to E plus P by 3 epsilon naught. That's it.